functions, and within it, some assignment hints. Yeah, built right into the lesson. Aren't you excited? Well, this is what we're supposed to already know. This page. This could have been the review lesson, this page right here, in the chapter about transformations. So, describe the transformations that are applied to the graph of y equals f at x to obtain these graphs. When the f at x is there, just to review, what we mean is, well, I'm not going to tell you what function is yet. Don't worry, I'll tell you. Before you have to do anything with it, I'll tell you what the function is. But if you didn't know what the function was yet, you could still talk about the transformations involved. How many is there? 2. There's 2 transformations. I can put 2 little dots under there. And I'm doing like a delaying tactic here. I'm going slow, giving you time to think and go, do I remember what the transformations are on this thing and where to get them? Vertical stretch, factor 3. Hold on. Vertical stretch, factor 3, because I'm multiplying the function by 3. That would make its y values multiplied by 3. What's the other one? Vertical translation, op 7.
Oh, Mr. Todd.
Yeah.
Can I have a sheet? I plan on doing some work today.
That was a good second line. You took away my comeback before I even was able to say it. Here you go.
This unit, I'm every day.
I love your positive attitude.
Oh, it's a sheet. No, the sheets are easier though. They're easier. I don't know how it's easier to write it down. I'm gonna write it down though.
Okay, friends, let's get back to example B, which I'm not going to charge you for. It will be a freebie. How many transformations do you see in this one? I see somebody saying 2 and somebody saying 3. It is actually possible for someone to call it 2 and incorporate the negative in there. But I think for most people this would be 3. First, a 1/2 out front. Vertical compression. Because it's smaller than 1, it's going to make it smaller. Vertical compression, factor 1/2. What about that negative out front?
Reflection on the x-axis.
Thank you, Reese. Vertical reflection in the x-axis. That is the y value switch from positive to negative or from negative to positive. And then finally the one inside Ben. Horizontal, shh.
Hey, he said.
Shh. No, I don't need your help. No,
Oh, sorry.
but thank you. You just
Sorry, Mr. Todd.
horizontal translation. Wait a minute. Right? Wouldn't negative be left? Like negative's left, isn't it?
No, it's not because it's in the brackets.
In the brackets does the opposite. So annoying, but so true. And we did a dance one day to talk about why it is true. That is, if you're looking left, it looks like you're moving right. Weirdly. Is this okay? If it is, good news. Like in advanced functions, if you're thinking of taking that course, like virtually every chapter there's a section on, oh, we've got a new function. Let's transform it. And the lesson is just, let's just go over the transformations again. So if you're getting this down pat, it's going to serve you well as you move forward. Except for this one. Oh, is it my fault? I don't know. So many people got this wrong on the test. Did I not make it? I'll blame myself. Yes? So what I'm going to do is I'm going to dramatize this. I'm going to ask Kyle. And if he gets it right, I'm going to be so happy. And if he gets it wrong, I'm going to be so mad. Okay, it's not you. I'm not mad at you. Yeah? It just works out nicely that it is you. But I'm going to act so mad like something's wrong. Hopefully, providing a dramatic moment that allow you to go, I'm going to remember that now. And then it's not going to happen to me next time. How many transformations is there?
How many transformations are there?
Yeah.
There are 3.
No.
2?
2 transformations.
Oh, because I thought like the one of them is unknown. Oh wait, no, that's for the base.
The F is just I don't know what the function is.
Unknown.
I can't actually do anything yet except talk about the transformation because I don't know what the function
So
is.
that's not a part. Okay, then
Yeah.
it's a horizontal compression of 1/2.
Yes.
I thought I was wrong. Wait.
No, it's right. Horizontal compression,
I knew I was right.
factor 1/2. And get ready, if he gets it wrong, decide if you know what the right answer is or not. Sorry, my pen is over on this side. It just fights me a lot there. Are you ready?
Yep.
And you're ready for the dramatic moment, too. You're going to handle it okay
Yep.
when I just totally freak out.
Yep.
I'm going to do my best to totally freak out if you get it wrong. Okay. And what's the other transformation?
Left 6.
No! Where are you getting 6 from? It's not 6. There's no way it's 6. This is incorrect. You can't go right 6 because it's not by itself. The x isn't isolated. The only way you could actually read the transformations is if it's isolated. How did I do? Did I scare anyone?
Right.
Except the factor.
Got to factor it first. Yes?
Mr. Todd.
And if you're annoyed by that, you go, well, why would you write it like that, Mr. Todd? I don't write it like that. I don't. Science, engineering writes it like that. As you're doing some work in there, the function will come out this way, and you have to know to bring that factor up front. So it's not a trick question. It's the way life works out when you're doing mathematics, that you got to watch out for these common factors.
I thought it was gonna be left because like I knew it was right, obviously, but you were
Right is right.
Okay.
It's right that it's right.
Because you were making
Yeah.
it seem like that was the part that I was gonna get wrong. Sorry, I was just like I'm just gonna say left.
Horizontal translation. Right 3. No, it wasn't the right part that most people got wrong. It was they went right 6. They just went what was done. And so you got to watch out for that. You got to watch out for that common factor. And unfortunately, it just appears in math again and again. The calculus people are starting to believe me now. The advanced function people still don't believe me. They believe I'm torturing them with common factors. The calculus people keep running into situations like, oh, it's a common factor. And then realizing that I was just preparing them for common factors. Will I put 100 like this in the test? No, but it'll be there somewhere. Just me hammered away at it. Is it okay? Here, maybe you should get a highlighter out for your study notes. And just highlight that and go, ah! When it's not isolated, the x needs to be isolated. That was fun. I enjoyed that. Thank you. Any questions about that? Total review of the previous chapter, which we did pretty good on. The results on the transformation stuff was pretty darn good. I was pretty happy. Okay, now into this chapter. Now we jump ahead into the stuff you got to know from this chapter. I know this is terrible Zoom, so I'm going to zoom to 400%. Oh, is that too much? 200%, and then I'll scroll around so you can only see parts of my table, but you should be able to see all of your table. Is it okay? You got your table there, so as long as I write big, should be okay. Today, the base function will be 2 to the x. Right from your assignment. I didn't do the assignment. Okay, we'll talk about that when we need to. In just a moment, I'll do a mini version of the assignment up here to review that. But if we want to vertically translate this thing down 4 units, has anyone got a shot at it? What it's going to look like? It's not that bad. Y equals yeah. Minus 4. So some of this is that what you said? Yeah. I couldn't quite hear. Some of this will be exactly what you expect. Outside the function is outside the function with exponentials. Now, if you get that, you're like, well, why am I here today? This is the exact same as before. Well, there is a couple little details coming here. Because look at this. Is that plus 8? Like, just ask yourself, is that plus 8 outside the function?
No.
No, it's inside the function. Outside would look like that. So weirdly, with exponentials, inside means inside the exponent is where the inside is. There, now I've taught most of today's lesson, except for the assignment stuff. Like, you might be like, I don't even know what 2 to the x looks like. Oh, well. Okay, I'm going to do a mini version of that in just a second. If you haven't got to the assignment yet, I'm going to cover that in just a second. But that plus 8 is inside. So the base function here is y equals 3 to the x. And there's one transformation. Because it's inside, it's a horizontal shift 8 units
I'm gonna say left.
left. Your brain tells you right, because plus 8 you'd think would be right, but it's not. It's left because it's inside the function. You're saying inside, but you mean like inside the exponent now. Good. I'll try and speak like that from here on in. I'll say inside the function, or like inside the exponent. I'll try and say both every time. Nathan.
I thought 2 to the power of x was the base function.
No. The first one, 2 to the power x, is the base function. This time the base is 3.
Okay.
So the base tells you which base function we're talking about here. The fact that they both say base in them is just a coincidence.
Okay.
But the base really is the base function this time.
Yeah. Okay.
So for instance, this one. Let's jump ahead to this one. Perfect timing. This one's y equals 4 to the x. So whatever that base is will be your base function, which again, it could be that we're in trouble a little bit because you're like, I don't even know what those look like. So let's get sidetracked for a minute. And you don't have to copy this down, but just know that this is the assignment thing. Now that you got that weekend to do that assignment, and you got an extra PA day, aren't you lucky that you have a PA day tomorrow? I'll tell you know. Do you know who has 2 thumbs and is not lucky that he has a PA day tomorrow?
You, Mr. Todd.
I would much rather hang out with you. All of you. I would much rather be here
Even
with
Kyle?
you,
Even Kyle?
Especially Kyle. No, we're making. Okay. Let's talk about base functions.
Oh.
And the one on the assignment, I believe, is 2 to the x. And here's how the table of values plays out when you do to it. You don't have this. That's part of your assignment. Okay? So you can just watch this as a preview to your assignment. Or when you go to do your assignment, you're like, I'm confused. You go back and watch this part of the video, and it helps you through it. See, aren't I kind here? Yeah, watch this. And you go through unknowingly picking x values. Was I suggest to do something like this when you don't know what x values to use. They might not be great x values. I won't say they always will be, but they will give you a hint as to what x values to actually use. Okay, so you go 2 to the negative 4, and you get 1 over 16. 2 to the negative 3, you get 1 over 8. 2 to the negative 2, you get 1/4. And I'm doing them in fractions on purpose. 2 to the 0, you get 1. 2 to the 1, you get 2. 2 to the 2, you get 4. 2 to the 3, you gave 8. And 2 to the 4, you get 16. Now, I did that fast on purpose. I'm hoping that you're capable of typing those into your calculator when the time comes. But let's check out what happens and the shape you get. Negative 4 is like 1/16. Like, that's really small. Negative 3 like 1/8. That's still pretty small, but not quite as small as that one. Negative 2, 1/4, right about there. Negative 1, 1/2, right about there. 0, 1, right about there. 1, 2, there. 2, 4, there. 3, 8, there. And 4, 16 is gone. That happens with exponentials very quickly. They grow very quickly and take off. And so what you get is this arrow saying, woo, gone. And then down here, and then it's like, and if you want to really understand what's happening here, watch this. 1/8, 1/16, 1/32s, 1/64, 1/128. I can't even graph them anymore. It's like approaching. It's so close to the x-axis. Never gets there, though. Never mathematically gets there. There's always a little bit there. So you get an asymptote here at y equals 0. It's approaching y equals 0, but never gets there. We haven't had, that was just like 1 over x had that before. And then this side just goes, woo, gone. How many people got that far in the assignment, or at least saw the shape of it? Okay? Some people ask me, several people ask me about domain and range. I'm like, graph it first. The assignment does say do that. It says graph. Go ahead and graph it. So get out a separate piece of graph paper, graph it out, and then you can pick off domain and range pretty easily. Domain's x element of reals, range greater than 0. Not greater or equal to 0. It never does equal 0. Answering most of the first questions, I think, on your assignment right there. Now, the only other type was, what if the base is 3, all that happens is this thing takes off a lot faster. Yep. That's pretty boring. Yeah? The other base could be 1/2, and what happens is you get this. And I'll let you do the table of values. I'm not going to totally do your assignment for you. Is you get this function here. It goes that way. Actually, I'm lying a little bit. In this lesson, I will essentially build this, but you get exponential, what's called exponential decay. See? Okay, exponential growth. This is populations like bacteria, viruses, cases of coronavirus, those type of things. exponential decay, this is more like radioactive breakdown. This is how they date carbon. They do carbon dating on bones to figure out how old a bone is, because the carbon decays like this exponentially over thousands of years. Okay? So those are the two basic applications of exponentials. Just to look ahead a little bit. You don't have to know all that. You just need those two basic graphs. Either asymptote on the left, off to infinity on the right, or coming from infinity on the left, asymptote on the right. Someone asked me, can they go below 0? Not the base functions. The base functions can't, but if you then move it down, it could go below 0. So we'll look at that in the lesson. Okay, back to here. What are the two transformations on this graph? This is where it'll be confusing. You'll think the 4 is a transformation. That's the mistake everybody makes in this chapter, but it's not. It's the base function. The 2 and the 1 are the 2. So let me just underline that. There's the transformations. How you're going for it? What are they?
Vertical stretch.
Yeah.
Factor of 2.
Vertical
and then
stretch.
Up 1.
Factor 2. And then vertical translation. Yes, I'm fine with the short forms. Unless you make up short forms. A couple of you on the last test made up some short forms, and then I didn't know what you meant. So be careful with that. All right. Oh, this is hard. This is difficult.
I got this, Mr. John. This is too easy.
Horizontal stretch factor 5, and it's got a 1/2 to the x there. Hold on.
No.
Where is the 5, when it's horizontal stretch, where does the 5 go?
In the bracket.
With the x.
The horizontal.
With the x. It goes inside the exponent. See, that's what's different this chapter. That's why you paid me to come in today. Inside the bracket, or inside the function, when I was saying that last chapter, every time I said it, I was like, or 2 chapters ago, I was like, it's helping them this chapter for me to say inside the bracket, but it's going to mess them up long term.
So it's 1/2 to the 5x.
1/2 to the 5x. So you've got to change your language slightly. Inside the function was what I should have said the whole time, but I didn't on purpose because I'm like, it'll help them way better if I say inside the bracket for now. But now I'm just modifying what I said and saying inside the function means inside the exponent. Best sentence today.
Wouldn't it be 1/5?
Inside, shh, just for a second. Inside the function, that wasn't the board's fault, that was mine. Inside the function means inside the exponent. Now, and I put the now in capitals to mean, yes, I know that's slightly different than how I was phrasing it before, but I did the best I could to help you through that chapter, now help you through this chapter, so I'm changing my words a little bit. Kyle, you have a question?
Yeah, wouldn't it be 1/5 because it's being stretched by
No, because that would be going inside the brackets, which the brackets were always the inside of the function before, but 1/2's the base function now. So the inside the function is the exponent.
You gotta put it with x.
Yeah, got to put it with the x. That's what someone else said too.
And that's on the outside.
Yeah, it's on the outside of the exponent. Well, no, it's on the outside of the base, the inside of the exponent. So a little bit difficult there.
Because before it was like horizontal, you would like change it.
Yes. Oh, that's wrong. After all that, I got so excited about my explanation, I used the wrong number.
1/5.
It's 1/5. I don't know how that happened. I was on a roll there, but this is a 1/5 because it's a horizontal stretch.
What? Mr.
So it's a
John,
1/5.
But I just said that though.
I thought you said 1/5 inside the bracket. So if you said 1/5 there, then you were totally right when you said that. I was just
That's what I was asking because I thought it was always 1/5.
yeah, you're totally right. But I thought you meant you wanted 1/5 in the brackets, which so I misheard you.
Thanks, Mr. Todd.
I was expecting.
Can you tell Liam to stop looking at his pencil?
9 different times. Guys, you were at 11.
Listen. When I'm dealing with my 7 and 10-year-old, this kind of behavior makes me really mad.
You're the 10-year-old.
When I'm dealing with my grade 10s,
Yes.
I'm disbelief. I say to them, what? What's going on?
You're making
Stop it.
yourself a lesson.
And you're still going. Be quiet. I'm going to separate you. What's the base here?
I think it's 10 bracket.
It's 10, yeah. Base means base here. And that's new thinking, I know.
I got this one, Mr. Fun.
How many is there? This helps people, and if you don't need it, that's fine. But it helps people to tell me how many beforehand. How many?
4.
I see 4. So do that beforehand. If you're having trouble with these, at least try to identify how many there is. Okay, so what do you got?
I got reflection on the x-axis.
Reflection. In the x-axis. Go.
And then I got vertical compression by a factor of 1 over
Vertical compression. Factor 1/5. And these are all muddling in your brain a little bit. You don't quite remember them all. I get it. I do. But here's another chance we have at nailing these down. We eventually got to get these nailed down. The last two are supposed to be easy.
Horizontal translation, right 5.
Horizontal translation, right 5.
And then vertical translation down 2.
Vertical translation down 2. Hopefully those last two, you're like, okay, those two I got. I remember those two. And maybe you're still working on getting the first two. I'm going to shift down here. I'm going to do a little horizontal translation. Oh, a vertical translation. Down a little there. This lesson acts like there. Good? Everything's good? I don't know that everything should be good at that point. You may need a few more practice ones to nail those basic ones down, but this next one takes it up a notch. Let's get the base function down at least. Let's get that part done before. What's the base?
1 over 4 to
Yeah.
x.
1 over 4 to the x, which again, if you're like, I haven't done
Oh, Mr. Todd.
the assignment yet, so I'm not super good at that yet. But why is this and why am I hesitating so much on the, Kyle's going to give me another chance to yell at him maybe. What is it?
Why is the 10 in the bracket? I mean, not in the bracket. This one is.
The 10 was in a bracket here?
Yep.
The 1/4 is in a bracket here.
Yep. But the base is just a 10.
The base is just the 10, just what's in the brackets. And the quarter is just what's in the brackets, just the base.
It's a fraction. 2.
I just don't get why the 1 over 4 is in a base like the bracket.
That's the whole base, 1 over 4.
Yeah.
That is the base here this time.
Oh, okay. No, so yeah, okay.
Yeah, no, it's a good question. Ben, factor that thing. It's going to drive you nuts. But I will keep going until I get through to you that the x has to be isolated for this transformation stuff to be correct. It's not a horizontal translation of 10. So I know it looks like there's 3 transformations, but you have to ignore the base. Once you've got the base function down, that's done now. The only transformations are here, so it's a horizontal compression factor 1/2, and it's a horizontal translation left 5. Now I'm sorry to tell you this, folks, but these transformations things aren't the most difficult mathematics ever. It does take practice, though. It's not going to just stick in your brain. You're not just going to look at it once and go, okay, I got it. You got to go out and you got to practice these. So important homework that way. Oh, this is a nightmare.
Oh, no. I know.
You got to factor a 1/2 out of 3. Got to divide 1/2 into 3. 6. Now there's 2 ways to think that through.
What if it's a negative though, right?
Yeah.
Oh, true.
One is just to go, what do I multiply negative 1/2 by to get 3? And the answer is negative 6. Optionally, you could go over here and go, okay, 3 divided by negative 1/2 is 3 times negative 2 over 1, which is negative 6. Okay, so you could do the division there. So what's the base function then, after all that? 5 to the x, because that's the base that we're talking about. And then I have 1, 2, 3 transformations. Horizontal stretch factor 2, horizontal reflection in y-axis, and then right 6. I'm over writing the whole thing out, horizontal translation. I'll just write right 6. That's good enough. What questions do you have? Two full examples in 20 minutes. It's going to be close. It's going to be close. Do you need more time there? I was trying to say it out loud as I was doing it there so that it was possible, if you can't see all the way up there, that you could still hear what I was saying. Right 6, yeah. More time? We're okay? Well, here's the full. What are you doing? Oh, I was too zoomed in. That's right. Well, I don't like that either. As big as possible is what I want here. That's all fine, but this is really what we're after. For the function y equals half x plus 4, determine the following properties and sketch the graph. Oh, negative a half x plus 4. Here we go. Oh, I know why I had that smaller. I wanted room for the table of values to help you, didn't I? There. There. Ooh. There. Okay. Base function. 1/2 x. That scares you? Good. We'll deal with it in a second. Transformations on the base functions. There's 2. Vertical reflection in x-axis and vertical translation up 4. I kept it simple for my first example. There's only 2 transformations there. Okay? I'm going to teach this like I did the other chapter, 2 ways at once. Table of values people and graphing people. You can do it both ways, and I'll teach them both at once. Table of values people will immediately build a table of values for the base function. See? I drew that straight. Look at the little hiccup there. But I drew it too big. So let me just tidy that up because I know I need a little space here. Table of values people. And you build a table of values for the base function. -3, -2, -1, 0, 1, 2, 3. And you plug those in. And here you get 1/2 to the -3 equals 1/8. 1/2 to the -2 equals 1/4. No, that's wrong. Hang on. 8. 1/2 -2. When you plug that in, you get 4. 1/2 -1, you get 2. 1/2 to the 0, you get 1. 1/2 to the 1, you get 1/2. 1/2 to the 2, you get 1/4. And 1/2 to the 3 equals 1/8. If I did that too fast for you, feel free to work on your assignment first to get good at plugging these things in so you get those numbers. So it's -3 is already up at 8. -2 is at 4. -1's at 2. 0's at 1. 1's at 1/2. Then 1/4. Then 1/8. And I'm going to write something down here that hopefully will help. Asymptote y equals 0. You should start to expect that in all exponential functions. They're going to have an asymptote on one of the two sides at y equals 0. Now, graphing people, once you have your base ones, I don't think you should draw the curve through it. It just messes things up. It's hard to see once you do that. But maybe you draw a really light curve through it. So light, to me, I'm going to use orange. I'm hoping that the orange, you can just barely see it. There's the base function there. Okay? I have two things to do. I have to vertically reflect in the x-axis, and I have to move them up 4. So, vertical reflection. These all switch signs. Does that ring a bell? But see, the graphing people will be very happy with that. This graph will now just be down at the bottom, that's all, going this way. So they'll be able to see what a vertical reflection looks like. It will look like this. I'm going to erase it in just a second. But after they do the vertical reflection, they'll end up with that. And they'll be able to see what's going on. The table of values people are like, I'm not sure what's happening here. Yeah, but the graphing people will just go, oh, I'll just flip all these points. I'll do that in a second. And then what is it? Up 4. And some of this is really scary in this chapter. These aren't. -4, 0, 2, 3, -0.5 plus 4. 3.5. 3 3/4. 3 3/8. Really scary stuff until you go, oh, asymptote moved up 4. This is helpful. This is the best help I'm doing. The asymptote now will be y equals 4. That is really helpful, table of values people. So you know where this thing's got to end up. It's all been moved up 4. So I'm going to put that on there. That's what we do in advanced functions. We get the asymptote right there at the start. We love asymptotes in advanced functions. We're like, there. Now I know where this thing's headed, and I'm a little less confused about the whole situation if I know where the asymptote is at y equals 4. Let me graph these points down. -3, -4. Oh, that's weird. Oh, I want to do another color. I'll do them all in red this time. -3, -4. -2, 0. -1, 2. 0, 3. 1, 3.5. Oops, 0, 3. Oops. Sorry, 0, 3. Sorry, I'm off a little bit here. Try those again. The scale's messing me up here. Start again. Start again. -3, -4. That I did right. -2, 0. There, that's better. -1, 2. That's right. -1, 2. 0, 3. That's there. 1, 3.5. Oh, getting really close to that. But I'm not surprised by that as it gets closer to that because that's the asymptote. See, by putting the asymptote on first, I know where this thing's headed. Oh, I could have used another x value there, couldn't I have? Yeah. So I'm going to go back to my table of values. And this is what I said about sometimes you won't know that you got a good table of values until after you do the whole thing. -4, you'll get 16. -16, and up 4 is -12. So -4, -12 is my next point there. So you might want to add another point on there after you have it there.
Oh.
Y-intercept, some people ask me that. They go, Mr. Todd, what's the y-intercept? Well, I'm graph first. You can get it right off there. Y equals 3. Equation of asymptote, y equals 4. Domain, x element of reals. And now the one I want to really pay attention to, range y element of reals such that y less than 4. Hard to predict that until after you've graphed it. Not that you couldn't do it, but wow, that would be quite a prediction to know that it was going to be y less than 4 before it even started.
So why is the domain? There's no domain because it can be infinite.
Yeah, you could plug any x value into this, no problem. There's no x domain issues. It looks like maybe it stops at a certain x value, but it'll keep going out and out and out and out and out and out. It'll take a long time, but it can keep going.
Wait, so it has to be greater than 4?
Less than 4.
Less than 4, yeah. Oh, because it's the opposite. Okay. Yep, yep.
And if the 1/2 to the power of negatives and building this initial table of values is causing you difficulties, well, that's why you were supposed to do the assignment first. And I don't say that in like a, well, you didn't do your homework that way. That's not what I mean. What I mean is now you're going to want to go work on that assignment to make sure you get the basics of graphing the two exponentials down, then come back to this and go, okay, now can I do it? Yeah. Any questions there? With 8 minutes on the clock. More time? Oh, we're getting faster. Oh, these are easier. Way easier when the base function is 3 to the x. It makes a lot more sense once the base function is a whole number, not a fraction. Okay? So, transformations applied to y equals f at x. Now this is what I was saying about, see that it's an f there, and we were first doing them like, well, what's the base function? How am I supposed to graph this? If you're going to have to graph it, I'm going to have to give you the base function somewhere. So this one is just the function notation. However, this is messy. Do you see how the x isn't by itself?
Negative.
You got a common factor out of negative, and so that becomes a positive in the brackets. That's the proper one. So now I can get the transformations. Horizontal reflection in y axis, and then left one and down 2. So the equation of the transformed graph would be y equals that horizontal stuff goes in the exponent. That's what in the function means. But just for fun, does anyone want to take a shot at these last 3 without graphing it? Just for fun, because anybody who texts me or emails me and says, how do I get the domain and range? I'm going to say, graph it. That's what I'm going to say, just graph it. But can anyone look at it and go, oh, maybe I can tell already, especially the first one, the asymptote, I think you can pick off just by looking at it. I see you, Kyle. I'm just waiting, patiently waiting. Someday when you're a teacher, Kyle, you'll see. I'll just wait and see. I'll give everyone a chance to think. And even if it's you that answers, everyone will have a chance to go, do I know this asymptote? Is it able to pick it off? Yeah? Y equals -2. Okay, so picking off at least the asymptote. Maybe I don't need to graph it to do that. And now that we've learned a little bit of exponentials, maybe you can take a shot at the domain too. You go, oh, for exponentials, the domain is just x element of reals. It might be the range that makes you go, maybe I better graph this first. You make a prediction. If you think you got it, you can write in the range what you think the range is, and let's see if it comes out the way you thought. Table of values. X, y equals 3 to the x. -4 to +4. Just plug those in, and I get 1 over 81. Whoa! 1 over 27. Yikes. 1 over 9. 1 over 3. 1, 3, 9, 27, 81. How am I doing that? How is he doing that? Is it just because he's old? Is that how I'm getting those? I'll do a couple of them, okay? 3 to the -3. What does negative exponent do to things? Changes them back to the denominator. So this is 1 over 3 cubed, which is 1 over 27. So I'm not doing anything fancy there. I'm just putting it down in the denominator. These ones are way easier, like 3 to the power of 4. That's just 81. That's not mysterious at all. But the ones with the negative powers. Mr. Tack, gonna use decimals? Well, yeah, but you're gonna have to round off, and what a mess. What are my transformations? Horizontal reflection.
Oh, left one.
Left one?
-1 then?
Yes.
Nice. And then down 2 for the other ones.
1, 0, -1, -2, -3, -4, -5. And then what? Down 2?
-2, yeah.
Ugh, 79, 25, 7, 1, -1. Duh! -1 and 2/3. -1 and 8/9. -1 and 26/27.
Oh, it's kind of easy.
-1 and 80/81. This reminds me of my kids at bedtime. Did your parents ever play this? Like, if you don't, no stories tonight unless you're ready in 10 seconds. You go 1, 2, 3, 4, and they're not ready yet. So you go 8, 9, 9.5, 9 3/4, 9 7/8. Did your parents ever do this to you? Giving you enough time to just make it? Oh, I made it in 10 seconds. Woo! That's what this is doing. It's getting closer and closer and closer to what? -2. That's all that's going on there. So do you need all those fractions? No, maybe not. Let me graph these. -5, 79. Seems like useless information, but it's not. It tells me it goes off the graph. -4, 25, too far. -3, 7, that's the first one I get to go on my graph. And you go, well, what's the point of those other points? Well, it just tell me that it goes off like that. I know what happens here. It's like, whooshka. -2, 1. -3. Hold on. I've messed myself up. -3,
2.
Yeah, what was I talking about? Oh, I was doing down here. I was coming the other way. Oh, that's okay. I was right. -2, 1. That's right. Then -1, -1. 0, -1 and 2/3. It's getting close to 2 already. 1, -1 and 8/9. It's getting close to 2 already. How many of these do I need? Not very many. It's getting close to 2, so this comes down to the asymptote at -2,
Oh, so -2. Oh.
which is the asymptote. Now I can do my range. Y element of reals such that y is greater than -2.
Oh, Mr. Todd.
Yes, sir.
It seems like, but is the asymptote, is it like the equation of the asymptote always the same as the range?
Yes, the equation of the asymptote is always whatever the horizontal, the vertical translation is.
Will that always be
And then the range, it'll either be greater than or less than whatever that asymptote is, because it's an asymptote. So there's a little tip on finding that, but I like graphing it. If you have any trouble at all, graph it first, and then you'll be able to tell what the domain and range are.